Hi, my name's Scott Hebbard from Sparx Systems, and in this webinar we'll present effective use case analysis in Enterprise Architect. There are many effective ways of writing use cases. However, in this webinar we'll focus on the tools within Enterprise Architect that assist with building use cases, structured scenarios, and generating downstream artifacts. Undertaking use case analysis is a well-established technique to identify and improve system requirements, typically associated with software or process design. Use case analysis is an iterative design process that examines how users can achieve system goals. On screen we have a number of actors listed that represent key decision makers for our shuttle launch. We've modelled a simple use case diagram that represents how the ground crew interacts with the launch pad in order to prepare for a shuttle launch. We've taken a user story to create a structured specification in Enterprise Architect that links to various states, uses, and results. The use case has a basic path or sunny day scenario, and it also lists an exception path. We begin by identifying all the main actors that interact with the shuttle launch, including the launch director, console operator, the shuttle crew, and of course the ground crew. The key decision makers are drawn as actors within Enterprise Architect and can be used on a number of different use case diagrams. There are a number of steps that need to be modelled in order for the shuttle launch to be timely, cost-effective, safe, and meet overall mission objectives. Mission control needs to consider factors such as weather conditions, fuel delivery, and ice and debris removal before a countdown can even commence. Enterprise Architect can model structured scenarios and automatically generate downstream artifacts. This webinar will model a shuttle launch and introduce effective use case analysis. We can use the model wizard to rapidly build our use case from an existing pattern, which includes sample actors and a basic use case. You can then use the toolbox or the spacebar to add a new actor. Provide the actor with a detailed description about the corresponding role. For example, the launch director has ultimate responsibility for approving the launch and can abort at any time. That brings us to the word abort. The underlined text refers to a glossary term. You can create a glossary term via the context menu. Glossary definitions help to ensure that everyone on the team understands the definition of key terms, helping to remove any ambiguity from the requirements definitions. For example, the term abort is a launch event that is used to signal the termination of a shuttle launch. We can now add other actors such as a console operator, shuttle crew, and the ground crew. Each of the key decision makers have now been modelled as an actor and have been placed on the diagram entitled Actor as shown on screen. To help the audience better understand our goals, I want to briefly look at a completed structured scenario, and then I'll step through the process of creating one from scratch. On screen we have 4 different actors that represent key decision makers for our shuttle launch. The diagram on screen is our primary use case. A system boundary outlines the interface between the ground crew and the use case to prepare the launch pad. Opening the properties on the use case, I can select the Scenarios tab to see a detailed structured scenario that outlines each step required by the actor and the corresponding system. In the bottom half of the dialog, we can see our basic and alternate paths listed, allowing us to easily switch between the two at any time. We also have a series of requirements listed. Each requirement is realized by a use case. Enterprise Architect helps to manage every aspect of use case analysis, including model traceability, requirement validation, verification, and testing. You can also use the Tools menu as an alternative method to access the Structured Scenario Editor. You can instantly access properties of a requirement with a single click. For example, the first requirement details that all ice and debris must be removed before the shuttle can be placed on the launch pad. The second requirement indicates that only the launch director can authorize for the shuttle to be tethered to the launch pad, and only after the debris has been cleared. Each requirement helps reinforce a sequence of steps and ensures that the launch is both safe and well structured. Finally, we have a number of states listed that describe the state of the launch pad at any given time. We can easily access definitions for actors and glossary terms to ensure that the entire team is always on the same page. So the example on screen is a finished structured specification which can be used to generate downstream artifacts. The exception path is currently displayed on screen. This path only occurs in the exceptional case when debris has damaged the launch platform. Use the toolbar to return to the basic path. We can now add to our structured scenario by including an alternate path. To do this, press the third icon on the toolbar. Provide a suitable name for the alternate path and indicate the step where the alternate joins. Let's assume that a user story has been written by a business analyst in a word processor. We can copy the text and paste it directly into the description tab of our structured scenario editor. Enterprise Architect has automatically highlighted any words that appear in the project glossary. Enterprise Architect will automatically generate out a structured specification using the context menu. There are two options. The sentence delimited option is used for a paragraph of text, while the new line delimited option is used for bullet points or separate lines, as shown with the example on screen. Enterprise Architect will attempt to guess if each step is a system or user step. You can see how easy it is to rapidly build a detailed specification based on little more than plain text. Enterprise Architect will define each step as either a system step represented by a computer icon or a user step represented by a stick figure. If any of these steps have been incorrectly allocated, simply click on the icon to override as shown on screen. You will also note on the bottom of the screen that the entry points or joins are clearly labelled for each path. Right-click within the Uses column and link to an existing model element. I plan on linking this step to a functional requirement stored within my model that describes ice and debris removal. The first step in the scenario indicates that the ground crew prepares the launch pad by removing any debris or ice. This step now uses a functional requirement that details what needs to be done. We've also established traceability between a use case, scenario step, and a functional requirement. Let's look at another example. Step 6 indicates that the shuttle needs to be tethered to the launch pad by the ground crew. Once again, this step uses a functional requirement. We can link to requirement number 2 entitled Tether Shuttle. Please note it is also possible to link to features or other model elements. We can also link to 2 or more requirements per use. During step 12, the ground crew undertakes the satellite payload changeout, and the step requires requirement number 3 entitled Payload Delivery. It is very easy to insert a use with little more than a few button clicks. The structured specification has 3 columns to store uses, results, and states. This information is valuable when managing traceability, producing downstream model artifacts, and diagrams. While I complete the process of entering additional uses, let's briefly review what we've covered so far. We started by using the Model Wizard to build a use case from an existing template. We adapted the template to suit our particular needs to model a shuttle launch. I illustrated how easy it is to describe actors and add terms to the project glossary to help avoid any ambiguity in our requirements definitions. Looking at a completed model, we saw how a structured scenario could be linked to uses, results, and states. I showed a series of requirements. Each of these requirements govern a key aspect of launch or safety procedures. I have also shown how you can easily add an alternate path and rapidly build a structured scenario from little more than plain text. Now let's return to our requirements. Use case analysis helps us to refine our requirements definitions. The diagram list view provides a text-based view of elements in a selected diagram. It is displayed in the main workspace and helps to streamline the process of adding elements such as requirements or features. We can easily add requirements with just a few mouse clicks, while the tabular view makes editing and reviewing a breeze. We can edit the properties of any element via their Properties dialog, or simply use the Notes view to make changes more directly. To access the Notes view, simply use the context menu and select Edit Notes. With the Notes view open, we can now click on each requirement to review the relevant notes in rapid succession. The example on screen now includes additional requirements that deal with robotic arm communication and safety. Many business analysts and developers that prefer text find this as a convenient way to rapidly document use cases or requirements. When you're finished, simply switch back to the diagram view. The diagram view is used to sort and arrange requirements, helping to clearly establish relationships and dependencies where they exist. For example, this diagram separates launch requirements from safety requirements. If I switch back to the Scenario tab, you'll note that the tab is empty until I select the relevant use case from the project browser. Now that we've added 2 additional requirements to our model, we can use and reference these requirements from within our scenario. For example, Step 9 indicates that the ground crew installs the Shuttle Remote Manipulator System, also known as a robotic arm or SRMS. This step now uses requirement 7 that establishes SRMS communication. Without this communication, you can't load satellites into the cargo bay. Step 11 indicates that the ground crew must ensure that SRMS is fully retracted, and this step uses a requirement about safety to ensure that the ground crew are not crushed during the retraction of the robotic arm. Once we have updated the scenario, we can save our changes. When you hover over a use, you'll see 3 icons. These icons allow you to access the properties, view and diagrams, or locate in the project browser. Upon reviewing the requirements, I noticed that I failed to use the correct naming convention. If I bring up the properties for the robotic arm, I can update and make these changes. If I switch back to the Scenarios tab, those changes are automatically displayed in my structured specification. I shall now record and store state information with respect to the launchpad. In step 1, the launchpad is declared not safe. This state will only change after the ground crew has cleared the ice and debris that may have resulted from a previous launch or adverse weather conditions. Once the ground crew has completed the cleanup, the launchpad state becomes safe in step 2. Each launchpad state has a significant impact on shuttle operations. For example, the cargo cannot be delivered to the launchpad until the launchpad is safe and in a cargo-ready state. Debris could damage the cargo, costing millions of dollars and endangering mission objectives. Other states include when the launch pad is considered to be tethered to the shuttle or when the robotic arm is retracted. Each of these states impact what the ground crew and shuttle crew are authorized to do, and use case analysis helps to improve the sequence of events and the robustness of the corresponding requirements. It is not until step 24 that the launch pad is finally countdown ready. Once you have completed entering all of the state information, select the Generate Diagram button on the toolbar and automatically generate your state diagram. I'm choosing to preserve my existing layout, however you can choose to lay out the diagram in a format that suits your individual needs. The state diagram clearly outlines the launch events and decisions that impact the state of the launch pad. This information can be analysed to identify safety problems or as a means to facilitate process improvement. The values in the uses, results, and state columns, whilst optional, are significant if you want to generate a diagram from the specification. We can generate an activity diagram with corresponding action. As we scroll down, we can see the various activity paths that are taken. This information can be used in use case analysis to better understand the activity required for a successful shuttle launch. You may choose to tidy the diagram layout and add additional detail or headings as required. Software is expected to produce results which can be documented in the results column of the structured specification. For example, step 13 produces the result that the payload weight is confirmed. This is obviously essential for calculating fuel loads and must be passed on to mission control and the crew to calculate escape velocity and achieve other mission objectives. This information can be used in downstream artifacts, diagrams, and even test cases to ensure that the system produces expected results. When you have defined a scenario, you can automatically generate one of a number of test cases from it, including a test suite in a horizontal layout, a test suite in a vertical layout, an internal test case, or an external test case. You can examine each test in a test window, outlining details such as who ran the test, who checked the test, the status of each test, and any acceptance criteria or input that is required to make the tests work. In conjunction to use case analysis, you can manage your testing within Enterprise Architect to validate your design. The assumptions, pre- and post conditions, basic, alternate, and exception paths are all source material for creating good test scripts and ensuring that your software produces expected results. Another valuable use case analysis tool is the relationship matrix. Select Tools followed by the relationship matrix to quickly identify any requirements that are not realized or dependent on a use case. Requirement number 6 determines if the launch pad is safe. I can use the context menu to rapidly find this requirement in diagrams or the project browser. I do this to investigate why it is not being used. Clearly, the requirement is crucial to shuttle safety. I can add the requirement to the exception path for when the ground crew repairs the launch pad. This process is a powerful technique to verify that all requirements are being implemented correctly and realized by a given use case. Finally, when I return to the relationship matrix, I can see that requirement number 6 has now been satisfied. In this webinar, we have discussed how to create an effective use case model. We learned how to generate structured scenarios from plain text. I outlined how to create glossary terms within Enterprise Architect. We successfully linked scenario steps to uses, results, and states within our model. We saw how easy it was to create basic, alternate, and exception paths. And finally, we automatically generated downstream artifacts including state diagrams, test cases, and activity diagrams. For more information about use case analysis in Enterprise Architect, please visit www.sparxsystems.com.